Here we go. So this is number 14, right? So it's number 14. Boy, that's crazy writing right there. I knew better than that. All right, so shaded area means the area under the curve is 0.77, right? So we're going to go look at our table, and a z-score of 0.7704, well, that's close to 0.77, right? So they're either going to want us to do one or two things. Find the average between these, right, which would be this, either between 0.74 and 0.75, and we could do that real quick. That's a point set. Well, let me do this. But they only wanted it rounded 2 decimal places. But I'm going to show you something. That's the 0.05 plus 0.7704 divided by 10, right? Okay, so what that's going to do is no, it needs to be the other one. My bad. I grabbed the wrong one. This one. Sorry. And that one. It's got to go up. It's in between these two, not the other one. Okay. Sorry. So it'd be 03. So let me go back. So let me do this again. B point, that's the 0.4 plus the 0.73 is, I can't do that. I can, it should be there, and that needs to see that right there. 0.7673. Add those, divide by, not 2, 10. So let's see. 0.7704 plus 0.7673 gives me, I don't know how to do that. My brain ain't working right. Divided by 10, so divided by 10. Right? So if I was to go, let's see, this is, we know that this one happens to be on the 0.7 scale, right? It happens to be 0.7704, right? If we were to back up to get what this one is, 0.03 is 0.7673. So if I back it up, that's 0.7704 minus 0.1538. That can't be right. Sorry. It's not averaging, it's the difference. Yep, that's, yep. Okay, hold up. Minus 0.7673 should be the difference. If I type that in, 0.673. All right, divided by 10 is each one of them goes, if I do that, each one of them will be 1. Okay. Each step is that much, right? So to go back, I would take to see if this is the answer, because this is just about there, but so I do 0.7704 minus 0.00031, and that would give me which is closer, right? But because they said go to 2 decimal places on this, right? Round to 2 decimal places. If I were to round this would be what? 0.04, right? That's closer to this, right? And if I wanted to look at 0.038, then I would take that 0.7701 minus 0.00031, and that would give me 0.7698. So I could step it back to find exactly the area of 0.77, which, okay, the answer is 0.04, right? And this is 0.7704, but this one really is the better answer as far as closer to 0.77. But because it has, it said go to 2 decimal places, this 9 makes that 3 go up, right? Does that make sense? So, all right, let me fix this right here. It's really 0.74. Okay, so we set up in iExcel 0.73 to 0.74, and we showed every place, the 10 places in between these two, right? The difference between every one of them is 0.0031. So what we did was we took this one, 0.73, added 0.0031, and just drug it up. Because this problem said 2 decimal places, the 0.739, which is the closest to 0.77, rounds up to 0.74, right? But you may run into a situation where it says don't. So the answer would have been 0.739, right? So you just you got to know that. And you can use iExcel, do that, or write it all out by hand, find the 10 places or whatnot. Or just find that and go down one. Right. One place is really all we had to do, but we had to find the difference, and that's where this came in, right here, right? So we went down one place. Right. All right. So nobody. All right. That was number 14. So the answer's 0.74. It's the outside number. The shaded area is the inside the table number. So sometimes you may have to interpolate to get there, okay? 4, 5, and 6, I took off the homework, and I really wish I would have put it back on, but I had people already completed the homework. I didn't want them to, because they would have wiped their scores out. But, and some people were in after yesterday's help session, but if you looked at number 4, and I worked it it was an interpolation, right? Interpolating between. So just remember that. All right, where else you want to go? Where you want to go, folks? So this is question number 18. So that's the area under the curve, 0.2989. So what we're going to do is we're going to look at the Z table. So we're going to look at my Z table, and I'm going to clear all my ink. Well, that stayed, but anyway, I'm looking for, let me go back. My brain went 0.2989, right? 0.2989. Well, it's not in the positives, it's in the what? Okay, so it's somewhere between here, right? 0.2989 is somewhere between 0.29. That's the difference between these two? Well, wait. Hold up. Your own point, yeah. But what we have to find is there one closer? Is that 0, 1, 2, and 3? So we got to look at 5, 2, negative 0.52, right? And negative 0.53, correct? Okay, so negative 0.52, its value is 0.3015, right? Negative 0.53 is 0.2981. Now, we got to find the difference between these, okay? Because it's almost there, but it's not. So what I have to do is I'll take and I'll go 0.3015 minus 0.2981 divided by 10. I want to see what those incremental steps are, right? Because I'm going to go down one to see if it's closer, right? 0.015 minus 0.2981 divided by 10. And I still get the same thing. So each step is 0.00034, right? Now, so if I'm here, so let's, okay, so I need to break that up into 10 spots. So that's 0.2981. This is negative 0.529, negative 0.528, negative 0.527, right? Dot, 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 all the way down to negative 0.52, right? So if I take and add this right here to this, so 0.2981 plus 0.00034, I get 0.2984. Well, that's still not what? 89, is it? So if I add another one plus 0.00034, I get 0.2988. I'm going to add it again. And I get 0.2991. Now, which one is closest to 0.2989? Be that one, wouldn't it? You see how I had to define my upper and lower? It's between these two. I took the difference, divided by 10, and then started adding to see if what I got. Does that make sense? So negative 0.528. So if I plug that in, because it didn't say round it, did it? On mine, it didn't say round it. So let's go negative 0.528. That's what I should put in. Negative 0.528. All right. Boom. There you go. Okay. So what I had to do is, do you see how each one of them, did the previous one step by that much too? No, it's 0.031, right? So it's going to be 0.003 something, right? This was 4, the other one was 131. So I knew I was closer, that it was closer on this end, right? And the numbers get bigger as I go to the left, right? So I just added 0.0034 to that and got that. Add 0.0034 to this and got this. And then I checked it out one more time. Okay. So you're finding the values, the exact value, as close as possible for the z-score, given the shaded portion, right? That's as close as we get. 0.2988 is close as we can get to 0.2989, right? All right. Are y'all seeing that? Okay. So that may be what you have to do sometime, is interpolate. Any questions on this one? So when we did the looking at the empirical rule, we understood that 68% of the data is between the first -1 and +1 standard deviation, right? And then 95 and then 99.7, right? So don't worry about these little decimals. This is 68, 95, 99.7 rule. But so one standard deviation to the left is 34%. One standard deviation to the right is 34%, right? So here's the mean right here. And we're only going, it has a standard deviation of 3, right? So that means there's 1 and there's 1. 1 below and 1 above, right? So how much is that shaded area? What's the probability that a random X value will be in that? Well, how much percent is in that? 68 what? Percent. Right? Now, looking at the one below, we have, there's 1, and now we're out to 2, right? But we're going below. So that would be 34 plus 13.5, right? So it would encompass these two. Let me grab. It would encompass these, only these two, right? So what's 34 plus 13.5? For line, 34 plus 13.5 is, what? It's 47.5. There you go. Yeah, so this, I would, if I were you, I would, this graph I've got right here that shows how much, like, we know that 34 and 34 is 68, right? We learned that back in the empirical rule. One standard deviation to left and right, 68% of our data. But if you look at each individual band, how much percent is it, right? And there you go. So there's 1, 2, 3, and then if you were to go to the fourth band, that's 0.15, right? 4 above. So that's, I would copy this right here down. Would take a picture of, copy down, put it in my notes. What I'd do. That'd be some smart stuff right there if you want to be able to get those. That way you just pick and choose where you're at, right? Add whatever percentages you are, right? Because it's laid, excuse me, it's laid out already in 3. It says standard deviation 3. So 1, 2, 3, 4, right? And then they laid out the numbers to the left. It's kind of like what you did on the first day, Monday, but now you're dealing with what's the probability, right? Fair enough. And this was what number? 19, 18, 17, what? 19. Number 19. All right. So, any questions? All right. So, this is number 13. And it said find the area between the two z-scores, right? So, I looked up negative 2.11, and I got 0.0174. And I looked up 1.59, and I got 0.9441. So, if the area between it, what it would be is 0.9441 minus 0.0174. Ladies and gentlemen, let's do it on the calculators. 0.9441 minus 0.0174. And I got 0.9267. So it should be that. So let's go see. 9267. Voila. There you go. No. You just gotta you gotta make sure you have all 4. Make sure you have all 4 of these, right? And then just the big one minus the little one, and that should give you the 4 decimal places. Should, right? Ah, well, sweetheart, you done it wrong 4 times, 6 times, okay? So, but it's okay. Now you see. But all right, so if we're looking at this, we have to use this equation: x minus mu over standard deviation, right? So that would be 71 minus 76 over 3, which gives me, they're going to 5, right? So let's see, 71 minus 76 divided by 3 is, you got a z-score, which is negative 1.6667, right? That's what I got. So let's go look at our table. Would we do that? Would we do this? We can check it. So this would be, well, I've got mine set up for 4, so let me do that again. Let me do the calculation again. 71 minus 76 divided by 3. Yeah, okay, so just add another 6 there. 1, 2, 3, 4, 5, 6, right? All right, so here's your value right here. Find the z-score for, okay, z-score is negative 1.666. 1, 2, 3, 4. 1, 2, 3, 4. 5, right? Okay, now, what's the probability that it's less than 71? So we got to go to the table. So they want how far they want. That's the problem. So let's see, son. All right, for this problem, and this problem is what problem was this? Number 21, right? 22. All right, so we got that as a z-score, but our z-scores only go to 2 decimal places. So we're looking at a z-score negative 1.67, which happens to be, we're just going to round them to 2. And this problem is going to allow us to do that. So negative 1.67 is 0.0475. Okay, we've checked it. We know that's what's going to happen, right? Now, they want us to do it again and find out what it would be for 78, right? So that would be, we use this formula up here. So that'd be 78 minus 76 divided by 3. Make sure you get 5 decimal places, right? 78 minus 76 divided by 3. And that is 0.66667, right? Which for z-score is going to give me 0.67. They're going to accept that, right? A positive 0.67. So if I go look on my table, 0.67, I get 0.7486. There, that's good there. And this one would be there, right? And then they say, what's between them? What's the probability between them? So we're going to take 0.7486 minus 0.0475, right? That's these areas, right? So 0.7486 minus 0.0475, and we get 0.7011. And the next digit is a 0, so I'm not worried about it. Okay. I guess I could put it to there. I could put it there. That's 5 places, right? All right. So on these, we found the z-score, and then we rounded to the 2 decimal places, right? So they wanted it all the way out to 5, and then to look it up, find out what its value was, we rounded it to 2, right? And that's where we got these values off of the z table, right? And we used for this value, we used 0.67. On this one, we use negative 1.67, right? Okay, as a z-score, we rounded 2 decimal places for that, and that they accepted that. So that should be good. All right. Any questions on that one? Okay.